Okay, girls, so now we're looking at example 2. Example 2 says Bertha stands in front of a church in Craddock in the Eastern Cape. She stands at point A and observes the angle of elevation from the top of the church spire is 60 degrees. And the bearing of the church from the observation point is 345 degrees. Now that's an important thing, guys, bearing. Remember, that's looking at north and south. So we've got our north and south that we need to north, east, south, and west that we need to adhere to. She then walks 5 meters due east and now finds the bearing of the church to be 315 degrees. Calculate the height of the church spire above the ground correct to the nearest meter. So firstly, we need to draw this. Okay, so here we have our church. Sorry, excuse my length. And here we have Bertha. She starts off on this side. The reason why she starts off on this side is because they told us that she walked 5 meters east to that point, right? 5 meters. Okay, that's the height of the building. That's the horizontal plane. So here in the horizontal plane, we've got to connect the base of the building to our points. Okay, and then we need to connect the angles of elevation and depression. So when she's standing here, she's looking up at the top here, and that's an angle of elevation. So I got to bring that all the way down over there, and I need to bring this one all the way down over here. Excuse the squiggle lines. I'm trying really hard to write nicely. We know that this is therefore 90 degrees, and that is therefore 90 degrees. Okay, because that's the building on the floor, and that's her walking. Okay, so let's fill in some information that they've given us. I'm going to write that in green. So they told us that the bearing of the church from the observation point is 345 degrees. Okay, so now I've got to try and figure out where is 345 degrees from this point. So I'm going to put my bearing on it. And I know that that is 0 degrees. This is 90 degrees. This is 180 degrees. That's 270 degrees. So in actual fact, when she's standing here, she's not looking up there. She's actually looking somewhere along that view, because all of this must be 345 degrees. Do you agree? Okay, now let's go look at this one. This one over here ends up being at a bearing of 315 degrees. We know that we go around in a clockwise direction, which is 270, which means she needs to look at almost that direction for this to be all the way around. Oh, and that ends up being 315 degrees. So there we end up having our information. There we end up having our line of sight. So this drawing isn't necessarily looking like this. I'm going to redraw this drawing, but I'm going to pause the video, otherwise it's going to take too long. Okay, so there I've redrawn this whole diagram. This is Bertha walking. Firstly, she's standing and then views the top of the church tower at 345 bearing, and then she moved 5 meters to the right or east, and then she viewed it at 315 degrees bearing. We're happy with that. Remember that bearing is not your elevation. It's 2 different things. So in the information that they gave us, they told us that the top of the spire, and they called it S, I'm going to call it A, let me just rewrite that as A over there, is 60 degrees. If she stands, let me just pause and then relabel these things. Okay, so let's look at it again. At the top of the spire, she's viewing it from point A, and it tells us that the angle of elevation that she views the top of the church is 60 degrees. So in here we can put 60 degrees. Okay? This is my horizontal plane. I just made it a dotted line so that you guys can see it a little better. That's 5 meters. Then it tells us that she moves due east and finds the bearing of the church to be 315 degrees. So if we look at this triangle over here, which I've redrawn over here, this is the base of the church. That is the point where she first viewed, and that's the point where she viewed it the second time, the steeple, okay? The bearings are related to the horizontal plane. So your observational points and the foundation of the church is in the same horizontal plane. Therefore, if I want to figure out what this angle is, knowing that this is 345 degrees, I know that I can go 360 minus 345 leaves me with 15 degrees here, right? And that is 90 degrees. So 90 plus 15 gives me 105 degrees there. Over here, I have 315 degrees. So I want to figure out what this angle size is over here. Now, I know that this line is 270. And how do I get from 270 to 315? Well, I add 45 degrees to it to be able to get that. Now, that's mathematically shown on the diagram. I'm going to show you how to write it out. So let's do angle A first. Angle A is equal to, we're going to figure out what that angle is, 105, right? So we want to go 360 degrees minus 345 degrees, which is equal to 15 degrees. And we want to add it together to get that full angle. So the whole total angle, you're adding 90 degrees to it to get 105 degrees. Number B, we know that we need to go backwards. So we want to go, we've got 315 degrees, but if I take 270 degrees away from it, I end up getting 45 degrees. And then angle C is equal to 180 minus 105 minus 45, which ends up giving you 30 degrees. Now we can actually start doing the work. Guys, remember, you want to find out what this height is. Let's change the colors here. We want to find out what that height is, which means my triangle BSC doesn't have any information in it, but my triangle CSA has a 60 degree in it. And that shares a common side with CAB. I want to know what this common side length is going to be. So I want to know what that is going to be. I have that angle, I have that angle, and I have this length. Remember, that's 5 meters. So how do I use it to calculate this side? I'm obviously going to have to, oh, and I've got this angle. What did we find this angle to be? 30 degrees. So I'm going to use this, those two, and I'm going to use B. I'm not going to use A to solve because that length doesn't help me at all. So now I go and I do my sine rule. And I'm running out of space. So my unknown goes first, AC over sine B, which is equal to AB over sine C. Put your little angles on them. AC we keep. We can rearrange this by taking sine B up, and I'm going to substitute everything at the same time in. AB's length is 5 meters. Sine B is sine 45. All over sine C, which is 30. You should be able to do all of this without the use of a calculator because these are special angles Remember to use your cast diagram for that. We end up finding out that we can find out AC's length, or we can just leave it like that and use that to calculate in triangle SCA. I'm going to erase this diagram on the side here and just continue this work over here. Okay, so in triangle SCA, we end up having, we have the right angle in this triangle that is opposite, and we've got adjacent. So I know that this is going to become tan 60 degrees SC over CA, or AC. Okay, we know what AC is, and we need to rearrange this to get SC by itself, and we can then times tan 60 degrees with CA, and I can substitute AC or CA into this, which is 5 sine 45 degrees all over sine 30 degrees times that by tan 60 degrees. If you plug that into a calculator, you should get an approximate answer of 12 meters. Do the sums, do the work, see if it comes up, see if you guys get the same answer. Be careful how you calculate these angles and using the bearing. Remember your aim. Your aim is to find the common side in the triangle with the most known information, so that you can find the side length in the triangle with the least amount of information. Okay, rewatch example 1 and example 2 if you need to, but now you can start exercise 6.3.